Hello everyone. Thank you for joining for another video of Calculus 1. In this video, I'm going to describe, I'm going to discuss some problems related to derivatives of natural logarithms. Basically, we're going to solve problems by using these two relationships that we obtained in the previous videos. d over dx natural log of x is equal to 1 over x for all x greater than 0. And also we're going to use d over dx natural log of f of x equal f prime of x divided by f of x. So these are the two equations that we're going to be using in this video for the problems. Let's take a look at the first problem. Find the derivative of y equals x times natural log of x. So I'm going to find dy over dx, which is d over dx x times natural log of x. Now I'm going to look at this as a product of two functions. One is x, the other function is natural log of x. And by using the product rule, I can write x times the derivative of d over dx natural log of x plus natural log of x times, that's the second function, d over dx x. That's the product rule. So we use the product rule. We use the product rule. Now x is there. D over dx natural log of x is 1 over x plus natural log of x d over dx x is 1. So from that we can cancel x to x in here, and then 1 plus natural log of x is the answer. 1 plus natural log of x is the answer. And the second problem, we have y equals natural log of x squared. Now we can either use the power rule that we learned in chain rule lesson. The power rule is d over dx. If you have a function of f of x, which is equal to g of x to the power n, what we can write is d over dx f of x, or d over dx g of x to the power n is equal to n times g of x to the power n minus 1 g prime x, right? So that's another relation that we have obtained in our calculus course. So you can probably use this for this, because if you assume that this part right inside of the parenthesis is g of x, so this is g of x squared. So I'm going to write now y d over dxy or dy over dx equals to 2 times, that's n, g of x, or in this case natural log of x, 2 minus 1 times d over dx g of x. So this is 2 times natural log of x to the power 1 in d over dx natural log of x. D over dx natural log of x is 1 over x. So you can write 2 times natural log of x divided by x. That's dy over dx. So that's the answer for the second question. And there are many other examples that we can use in this way. Let's consider another example. Consider another example. So we can use something like this. D over dx. So we find y equals, find the derivative y equals x squared natural log of x. We can write dy over dx equals d over dx x squared natural log of x. And I can use the product rule again. X squared taken out, and then you find the derivative of natural log of x plus natural log of x taken out, and then you find the derivative of x squared. From that I can get x squared 1 over x, that's the derivative of natural log of x, plus natural log of x, this is 2x. So then I can cancel these two, and then I can take x as a common factor out, 1 plus 2 natural log of x, 2 times natural. This is dy over dx. So that's problem. And we're going to use the other relation, or we can use actually the chain rule for that without quite remembering these functions. But anyway, so I try to relate the other equation as well. So if you had an instance d over dx natural log of f of x, in that case you get f prime of x divided by f of x. This is a consequence of chain rule applying on natural log of x function. So let's find the solutions for these. Find the derivative of y equals natural log of x cubed plus 1. So this is y equals. So if you want to find dy over dx, you can write d over dx natural log of x cubed plus 1. Now, according to what we see in here, this part is our f of x. So the solution would be according to this equation. I'm going to show you two ways of doing this. F prime of x divided by f of x. So f prime of x is d over dx x cubed plus 1 divided by this f of x in this case is x cubed plus 1. So if I use the summation rule, it's going to be d over dx x cubed plus d over dx 1, and you divide it by x cubed plus 1. And then you get the first term is 3 times x squared plus this is 0 divided by x cubed plus 1. And then you get 3 times x squared divided by x cubed plus 1. That is dy over dx. And the other way, the alternative way, is to directly apply the chain rule uh, on this problem. Let's see how we're going to do in that way. I'll use another color for that. Dy over dx is equal to d over dx natural log of x cubed plus 1. So in this case, what I'm going to do is I'm going to take this as u. So if I take that as u, I can write the chain rule. I can write the chain rule d over du natural log of u times du over dx. So natural log of u, d over du natural log of u is 1 over u. We learned previously, plus 1 over u. And d over dx, u is x cubed plus 1. So 1 over u is x cubed plus 1. 1 over x cubed plus 1. 1 over x cubed plus 1. And this is d over dx, x cubed plus d over dx 1 using summation rule. So the first term inside the parenthesis is 3 times x squared plus second term is 0 and it's divided by x cubed plus 1. So you get the same answer, 3x squared divided by x cubed plus 1 in that way as well. So we use what we used here uh, is a combination of chain rule and the logarithmic derivative rules we learned in this lesson. So that's how you work out a problem like that. And we can do another problem. Find dy over dx if y is equal to uh, natural log of uh, square root of sine x. So we can do it in either way, as I explained to you earlier. We can find this is dy over dx, d over dx, natural log of square root of sine x. So what I would do is I would take this as f of x. So the solution would be f of x divided f prime of x divided by f of x. So f of x is square root of sine x, and f prime of x is d over dx square root of sine x. Now to take the derivative of the square root of sine x, we can use the power rule, or we can use the chain rule. If I use the chain rule, what I would do is I would take this part sine of x as u. So if that is u, then I can write this is 1 over sine x and d over du multiplied by d over du sine u d over du d over du u to the power half, because u is let u is sine of x, right? And then you have d over dx u, which is sine of x. Hmm? So this is square root of sine x, and if you integrate this part, differentiate d over du u to the power half, it is half u to the power negative half, and this is d over dx sine x is cosine x. So now u is sine x. This is 1 over square root of sine x. So you have 2 times 1 over square root of sine x times u to the power negative half is 1 over square root of sine x times cosine x. So square root of sine x times square root of sine x is sine x. So you have half sine x over cosine x. So cosine x over sine x is cotangent x. So you can write half cotangent x. That is d over dx natural log of d over dx natural log of square root of sine x. So we can actually, by using the basic rules that we have learned so far, we can solve any kind of problem like this. Uh, let's take some other problems. One other problem. If I were to use a problem like this in here, I can use find, okay, it's color, find dy over dx if y equals natural log of 9 x squared minus 8. You can either use the law that we learned or the chain rule. Now, if you're really good at chain rule, I would recommend you using chain rule. Let's use the chain rule for this one. Dy over dx is equal to d over dx uh, natural log of 9x squared minus 8. And I'm going to take this as u. So we can take d over dx natural log of u. And if I apply chain rule, this can be written as d over du natural log of u times d over uh, dx u. So here u is equal to 9x squared minus 8. So for natural log of x, the derivative is 1 over u, and d over dx u is d over dx 9x squared minus 8. And instead of 1 over u, I can write 1 over 9x squared minus 8. And then I can use the summation rule for this, d over dx 9x squared minus d over dx 8. D over dx 8 is 0, but d over dx 9x squared is 9 times 2 times x. 9 times 2 times x divided by 9x squared minus 8. So this is 18x divided by 9x squared minus 8. So that's dy over dx. So what we did was we used the chain rule effectively here to solve that problem. Uh, and you can use many other problems like that. For example, uh, let's look at this problem. Uh, find the derivative of y equals natural log of natural log x cube. Uh, you can use the power rule that we learned, or you can use the uh, chain rule. So if you use the power rule, this can be written as d over dx y is equal to d over dx natural log of x cube. So your power rule three times natural log of x 3 minus 1 times d over dx natural log of x, right? And this is 3 times natural log of x squared. And for this, actually, I can assume this as f of x, or you can use pretty much chain rule. So let's use the chain rule. Let's use the chain rule because this is u. And then you can write this as uh, d over du natural log of u times d over dx. U here is equal to natural log of x. So this is 3 times natural log of x cube. This is 1 over u, that is 1 over natural log of x. This is 1 over u times d over dx ln x, or natural log of x is 1 over x. So we have 3 times natural log of x cube divided by u is natural log of x times x. So that's our final answer. That's our final answer for that problem. So if you use your basic knowledge of chain rule and the things that we learned earlier, natural logarithmic derivative of natural log functions, you should be able to solve almost any problem. Okay. Okay. Thank you very much for listening. See you all.